The 25th question in kinetic theory of gases is the amount of heat energy required to rise the temperature of 1 gram of helium at NTP from T1 degree Kelvin to T2 degree Kelvin is. You know very well the amount of heat energy required. The amount of heat energy required to rise the temperature of a gas is, okay, what is that? Is delta Q is equal to N into Cv into delta T. Here the amount of heat energy required to rise the temperature of 1 gram of gas, 1 gram of helium gas at NTP. That means here natural temperature and pressure. That means here volume remains constant. So according to given question, we understood what volume remains what constant, isn't it? So for given what is that? Given helium is here helium gas is monoatomic. So you want to calculate delta T. You have to know what is delta Q and what is N and what is Cv. Then you have to calculate the required. So for here helium is what? Monoatomic. Okay, for monoatomic gas, Cv, specific heat of gas at constant volume, is nothing but 3 by 2 into R. Okay, and whatever the temperature of this gas, 1 gram of helium gas is raised from T1 degree Kelvin to T2 degree Kelvin. That means delta T, rise in temperature, is nothing but what I say, T2 minus T1 Kelvin. Okay, but N is not given. Okay, so you should calculate N value. What is that? Here N is the number of moles presence in given mass of gas. N is equal to what? Number of moles present in given mass of gas. Given mass of gas. What is this formula? N is equal to mass of gas in grams by its molecular weight. Therefore N is equal to, here mass of given gas. What is the mass of the given gas? 1 gram. What is that? 1 gram, isn't it? So 1 gram by molecular weight. What is the molecular weight of helium? It is nothing but 4 gram per mole. What is it? 4 gram per mole. So therefore N is equal to, that means the number of moles present in 1 gram of helium, En, is nothing but what I say, 1 by 4 mole. 1 by 4 mole. So all quantities have, therefore delta Q is equal to the amount of heat required to rise the temperature of N moles of gas at a constant volume. Delta Q is equal to N. N means what? 1 by 4 into Cv, specific heat of gas for monoatomic. Why? Because here helium is a monoatomic gas. For monoatomic gas, Cv is equal to what? 3 by 2 into R into delta. That means what? T2 minus T1, isn't it? So therefore delta Q is equal to 3 by 8 R into T2 minus T1. So this is the required answer for this question. That's it.